So let's take a look at the graphs of cosine and sine here using this little interactive unit circle. The graph of cosine and sine are very similar. The only difference is you can see here cosine, remember cosine is the x-coordinate. Cosine starts off at 1 on the unit circle, and then as we go up to pi over 2, cosine is at 0. And then as we go to pi, cosine goes to -1. That reaches its minimum at that point. And then it continues on to 3 pi over 2, where it is again 0, and then 2 pi over 0. It has completed a full cycle, and it is now at 1 again. Okay, so cosine starts off at 1, goes down to -1, and then ends here. I shouldn't say ends here, but the period ends at 1. Now let's go to sine and go back to 0 pi. And you can see visually at the bottom, sine and cosine are very, very similar. The only difference is at 0, sine is 0, right? Because the y coordinate at 0 is 0. So that's the only difference. Then you go up to 1 as you go to pi over 2. As you go to pi, it's down to 0 again, the midline. At at 3 pi over 2, y is -1, so that's where it's at its minimum. And then at 2 pi, beginning the cycle all over again, it's back to 0. So let's just look at the two differences here between sine and cosine. Okay, so here is the two graphs. You know when you got these waves, you're going to have either cosine or sine of x. And the big differences there are when x is 0, or 0 pi, cosine is at 1, and when x is 0, sine is at 0. Now let's look at tan. The graph of tan doesn't look like cosine or sine, and the reason for that is it is undefined. And when is it undefined? Remember that tangent is sine over cosine. So wherever x is, why is that thing going out this way? Wherever x is 0, it's going to be undefined because y over x would be a denominator of 0. So you can see right here, it's kind of hard to do this, but at 0, there we go. That would be 1 over 0, so it's undefined. So that's why you have asymptotes. You have asymptotes here at pi over 2, 3 pi over 2. Anywhere where pi is over 2, you're going to have an asymptote. Which is why the graph of tan has all of these asymptotes. Now, they don't have the graph of cotangent here, but cotangent would be very similar, except its asymptotes would be when y is 0. So that would be here at pi, at 0 pi. That's where cotangent would have it. So let's look at those. So tangent and cotangent are very similar. You'll notice that with tangent, the equation kind of comes up and bends to the right. And you also have asymptotes at pi over 2 plus pi. Whereas cotangent, the lines tend to bend to the left and up. And another key giveaway there is that we have asymptotes at 0 plus pi, or multiples of pi. So 2 pi, 3 pi, all that. So that's how you can tell the difference between those two. Now, to understand the graphs of these other reciprocal functions, let's look back to what cosine and sine were. So secant is a reciprocal function of cosine. So at 0 pi, if cosine is 1, secant will be 1 over 1, which of course just be 1. Okay. Now, what about when cosine is 0? Well, that would be 0 over 0, which is undefined, because we have a 0 in the denominator. Next one here, we've got -1. Well, what's the reciprocal of that? Well, that'd be -1 over 1, which would just be -1. 0, well again, 0 over 0 is undefined. And then last one would be 1 over 1, be back to 1. So let's take a look at the graph of secant. And here it is. Very distinctive looking graph. We can see undefined, undefined. So undefined at pi over 2, asymptote. Undefined at 3 pi over 2, asymptote. it has it starts out at 1, and then when we are at pi, it's -1, and again right there. So that's what the graph of secant looks like. Now let's look at cosecant. That's going to be very similar with just one difference. Obviously, cosecant is going to be undefined at 0 pi, because that would be 0 over 0. Then here we'd have 1 over 1, so that'll be at 1, undefined again, and then it'll be -1, and then undefined again. So let's go grab that graph. Okay, again, very similar. We are undefined at 0 pi, pi, and 2 pi. You can see here there are vertical asymptotes at each of those locations, and we notice that at pi over 2 it's 1, and 3 pi over 2 it's -1. So there's a quick recap of our two reciprocal functions there, two of the three reciprocal functions, and just the slight differences. Asymptotes are going to be at pi over 2 and 3 pi over 2 and 5 pi over 2 for secant, and it's going to be just at pi, 2 pi for cosecant. Now lastly, we've got the inverse trig graphs. And inverse, remember, is different from reciprocal because inverse switches the x and the y coordinates. You can see that best here on the first two graphs. We've got y equals inverse sine x. Now, under sine x at 0 pi, the output is 0. So in the inverse sine, you would have a 0 and an output of 0 pi. You can kind of see that. But we can see it better here. We have pi over 2. The output is 1. So in the inverse sine function, right here, that's going to actually be 1 with an output of pi over 2. Now, you might be wondering, hey, why does this stop? That's because if this were to continue, it would no longer pass the vertical line test. It would no longer be a function. So we actually have to restrict the domains in order to make these inverse graphs functions, or inverse trig graphs functions. Otherwise, if they were to continue, they would break the vertical line test and they're no longer functions. So these are kind of a dead giveaway when you see this graph and you see that the domain has been restricted, because that only happens on inverse graphs. And if you notice the cosine, we can actually see it better here because just the way the graph's oriented. The graph of cosine at 0 pi, the output is 1. So that means in inverse cosine, we have 1 with the output of 0 pi. And you can kind of see right here where that's working out. Here is 0 pi 1 right here, and then 1, 0 on the output. Then we got pi over 2 on cosine, which is right here, and then 0 and with an output of pi over 2 right there. So that's how the inverse graphs work. And then tan also have here, but the tan's a little bit different function, so we just kind of recognize it by its shape here. It almost looks like a really kind of a not really nice drawn S, where it kind of tails off to the left and to the right in opposite directions, going to infinity. So that is inverse tan. So this lesson is called the 9 graphs, identifying 9 graphs, and that's my dog. That's the 9 of them right there. So cosine and sine are very distinctive. They're wavy. You just have to look at where is the output when we have 0 pi. Tan and cotangent are very similar, but the asymptotes are in different places, and it also, tan goes up and to the right, whereas cotangent goes up and to the left. Secant and cosecant look very similar as well. Just have to look for those asymptotes where those are. And the inverse trig functions are pretty easy. They'll have a restricted domain for the most part, and they will also just be the inverse. They'll just be switching the x and the y axes for the original functions, sine, cosine, and tangent. Okay, so write the equation represented by the graph below. What we can see right away here, I'm just going to grab this real quick, grab a screenshot. We know it's an inverse trig function. So we'll come here Paste it. Okay. So in this one, we can see that when x is 0, we have an output of pi over 2. And, come on, there you go. And when x is 1, we have an output of 0 pi. Okay, so the original function at 0 pi, we'd have an output of 1. And at pi of 2, or 90 degrees, pi over 2, we're going to have an output of 0. Okay, that's clearly cosine. So this is going to be arc cosine. We could say arc cosine, or we could just write it cosine. Whoops. Yeah, Surface Pro's slumping a little bit there. Or we could say inverse cosine. So let's go back here. Type that in. Y equals, and I'm just going to type in arc because it's easier. Arc cosine x. Yes, I'm sure. Got it. Okay, let's try another one. Okay, well, there's only one graph that looks like this, and that is tan, right? Tan is the only one that kind of looks like that snake. So that's going to be, or I should say inverse tan. So y equals arc tan x. Once again, you could just write tan to the negative 1 power x. That would be fine too. So these tend to be pretty easy. Okay, so this one, we can see it's either sine or cosine, and you can see at 0, it's 1, that's cosine. Y equals cosine x. So as you're doing these, you can just nail them down pretty quickly, just based on what they look like. So, you know, oh, well, that's tan. We already did that one. Okay, so this is either cosecant or secant. We notice that there's asymptotes at pi over 2 and 3 pi over 2. So let's go back here. If my Surface Pro lets me. Hold on a second. The asymptotes at pi over 2 and 3 pi over 2, that's secant. So let's go back here. There we go. Y equals secant x. Yes, I'm sure. So this ends up being pretty easy. This one is going to be sine. This is going to be very similar to the other one that we had, but just to show you, you can just do like, whoops, negative 1. You can do it like this too. Submit. Yes. So after a while, I mean, there's only 9 graphs, so you can kind of spot them pretty easily after that if you just know their features.